Alright, this video is going to talk about solutions, and we're going to dive a little bit more into homogeneous mixtures. Just to recap, matter is divided into two main groups. There are pure substances. Those are made up of only one type of particle. So once again, just to clarify, I thought this might help to clarify this. A pure substance is made up of only one type of particle, whereas a mixture is made up of at least two types. Okay, so a pure substance would be like your elements, your compounds. Well, they're all the same. All the particles that make them up are the same. Now, a compound is a combination of atoms, but they're chemically bonded together, like water, H2O. Each water has compound is H2O. They're all the same particle that make them up. Mixtures is a mixture of two types of particles. Okay. And then there's two types of mixture. We've already talked about this. Heterogeneous mixture. It's where you can noticeably see the difference. You can noticeably see the difference, the different parts that make them up. All right. Not distributed evenly. We've got vegetable soup. We got sand and water. We got oil and water here. We got like a vegetable oil there. All right, so you can visibly see the different parts that make up those mixtures. Homogeneous mixtures. Once again, just to recap this. Once again, the word homo, if we think of it as the same. All right, homo means the same. It all looks the same. Cannot be distinguished from one another. Okay, particles are evenly distributed throughout air, salt water, if mixed thoroughly. 10 karat gold. All right, you might say, well, gold's an element. Yeah, but 10 karat means it's not pure gold. Right? There's other things mixed into it. All right, so homogeneous mixtures can also be solutions. Now, a solution is it's separate particles not visible because of this dissolution. So like salt water, for example, you can mix salt and water so thoroughly together. So this is when they are mixed so thoroughly together that it's really basically the salt particles attach themselves to the water molecules and it becomes almost indistinguishable even at a molecular level. It's very hard to notice the difference between the two particles because it's so finely mixed together. So what happens is in salt water, the water is and we're not going to get too much into it, but basically water has a slightly positive and slightly negative end, and it can really be used to pull a lot of different materials into it. Okay, and so it can attract many types of materials. I don't want to get too crazy with the polarity of water because we haven't talked about it, but so in salt water, there's two parts to a solution. There is the solute, which in this case of salt water, that's the part that's getting dissolved. It's typically the one that is in the smaller quantity. And then there's the solvent. That's the larger quantity. All right. So you can ask yourself, like, what state of matter is it in? Like if I say salt water, which one's the solute, which one's the solvent? Well, the solvent, that's salt water, is in a liquid state. So obviously the water is the larger quantity, so that's the solvent. Water is almost always going to be the solvent for what we talk about. Not always, but it's a very good solvent because, like I said, the polarity of it. So the solute is the smaller quantity. Now you can think, the easy way to think of this is solute. If you count the 1, 2, 3, 4, 5, 6, it's only 6 letters, whereas the solvent is 7 letters. So that solvent is a larger word. It's going to have a larger quantity. Solute is a smaller word. It's going to have the smaller quantity. The solute is what is getting dissolved into the other substance. Okay, so that's going to be a key distinction. I'm going to ask you questions about that as we go. Why do some substances dissolve and others do not? In a solute, each particle is attracted to each other. When the solute is placed in the water, that new attractive force is present. That's what I talked about with like the polarity of the water, how it has a positive and a negative end, slightly positive, slightly negative. And sometimes that attractive force between the water and the solute is strong enough to pull it together, and sometimes they're just not attracted. All right, solubility. That's another word. That's how much can be dissolved, how much of a substance can be dissolved at a given temperature. All right. The maximum amount of solute that can be dissolved into a solvent at a specific temperature. All right, so solubility is how much you can dissolve in something at a specific temperature. And we're going to talk about how temperature affects that, because we should know by now what happens when we increase the temperature of something, the particles move faster. And so if the particles are moving faster, then you're going to be able to mix more in. They're going to be moving faster. You're going to be able to get more mixed in there. So the temperature is going to affect the solubility of a substance. You'll be able to mix more in. Every chemical substance which dissolves in water has a fixed solubility. If it doesn't dissolve, it's zero. All right, the solubility is zero. All right, so it's the same every time. What that means is a fixed solubility means it's the same every single time. So every chemical substance at a given temperature, salt will always dissolve into water this much at this temperature all the time. All right, it has a fixed solubility. There's only so much that can get poured in that can get mixed into it. All right, and if you can't mix in anymore, all right, then it would just settle to the bottom. All right, that's where you get a lot of like. Sometimes if you're like making hot chocolate or something, you mix it in, it can only hold so much, and if it can't hold anymore, it'll just settle to the bottom because you have too much of that powder, and it won't get pulled into the solution, so it'll just settle. Some of the terms: saturated means you can't mix in anymore. It's got the maximum amount. Anything else you have is just going to settle to the bottom. All right, so saturated solution means you cannot mix anymore. It is full. All right, unsaturated means you can mix more in. All right, it's less than the maximum amount. All right, it's unsaturated. You can mix more in. Go ahead. Now, supersaturated is a weird one because it has more than the maximum amount. And you might say, well, how the heck is it possible to have more than the max? It's like being more than 100%. It's like you got to give 110%. That's not possible. Well, in a solution, it is. It basically involves like raising the temperature and then dropping it really quickly, mixing a lot in and then dropping it quickly, and it forms like a crystal structure. It's actually kind of cool to see that, but that's pretty rare. Diluted means it's less concentrated. All right, and so we're going to do a solutions lab here in a little bit, where we're going to show how the temperature is going to affect the solubility. All right. Now, I'll cover this separately.